Good evening, everyone. Let us start with today's session. Welcome for today's second live session for this Smart Grid Basic to Advanced Technology course. And I'm Gagan Meena and I'm doing
Good evening,
PhD.
sir.
Yeah, good evening. So, I'm Gagan Meena and I'm doing PhD at IIT Bombay in Power System Engineering. So, this will be the agenda for today's live session. We will first go through an overview of week 2 material that was discussed in the lectures, and we will discuss some questions, and in between also, depending upon the question, we will discuss some related ideas or content, and then finally we will take your doubts. In between also, if you have any doubt, you can ask. And just to remind you, the deadline for assignment 1 and 2 is August 9th, that is tomorrow. So please submit the assignments on time. And also the links for these live sessions is available on this YouTube channel, so you can go and watch. And it's also available on the portal. Now they have updated. The problem solving session tab is there where you can go and access the links. Just before going to that overview of week 2, I just wanted to tell you about this new standard which has come up. So in the last session, uh, in the week 1 also we have discussed different types of standards for smart grids. One of them was interconnection of DER, the distributed energy resources. The standard for that is IEEE 1547. So it is, the full name is Standard for Interconnection and Interoperability of Distributed Energy Resources with Associated Electric Power System Interfaces. So this is mainly meant for distribution level for microgrids, not for transmission system. But however, there was no such standard for transmission system, and several many people they started utilities they started using this same standard at transmission level. And as a result, there were several incidences which resulted in generation loss. We can see the table here: May 21, July 20, 2016. All these around almost 1 gigawatt of generation is lost because of this misuse of this standard. Considering these events, and yeah, because of this, there was no uniform interconnection requirements for bulk system connected inverter-based resources plants, in which led to ambiguities and inconsistent IBR implementations. So IBR is here is inverter-based resources. As a result, to overcome this challenge, this new standard was introduced for transmission and sub-transmission level. So this is IEEE 2800. It was it just came up in 2022. So this is standard for interconnection and interoperability of inverter-based resources interconnecting with associated transmission electric power system. It's specially meant for transmission system. Given the scenario that most of the generation now, big solar and wind farm, we will also see in the subsequent slides that now even gigawatt level of solar and wind farms are being developed. They are in operation, so they the new plants will be even much bigger. So they certainly require such standards so that any kind of fault, any kind of disturbance do not affect the entire system. So we can tackle each and every kind of situation. So this was just a Just to give you an idea that we have new standard transmission system. So we have separate standards for transmission and distribution systems. So now we will go through overview of week 2. So I have provided link in the slides. You can go through if you want to read more about 2800. In week 2, initially it was a continuation of the week 1. So elements and technology of smart grid was discussed. Yes, Makaran, do you want to ask something? Makaran, can you hear me? You have raised your hand. Do you want to ask something? Yes, so let's move it. So the first lecture was on SCADA, supervisory control and data acquisition, and smart metering. Then we discussed about two distributed energy resources, which is most prominent around the world. So one is solar and another is the wind. This was the first one for SCADA, which is the supervisory control and data acquisition. So SCADA has three main parts. So its three components are: first one is the master station, also called as energy control center, which communicates with all the field equipments, with RTU and other IEDs, intelligent electronic devices. So master station has these five other components. First is data acquisition server, which will acquire data. It interfaces with the devices via communication. So RTU will communicate with the master station. So that interface is provided by the data acquisition server. Then we have real-time database server where real-time data is monitored. Then historical servers are there where old historical data are available, which can be used further for any kind of analysis or offline estimation. And real-time data server can be used for online estimation. Then we have application server, which are used for running different type of applications, which can be used to generate any kind of control actions which are required to control any of the equipments. Then there are operator workstations. The second component is remote terminal unit, which is also known as remote telecontrol unit, and it also has several components like the central real-time database, which interfaces with all the other software modules on the RTU. So RTU is a microprocessor-based device. So it has both software part and its hardware component. Its physical I/O application, it interfaces, it acquires data from the RTU hardware components from its input-output channels, which are analog or digital. So they can receive both analog and digital output and can also provide analog and digital outputs. And then there is data collection center, which will collect data from the devices which have communication capabilities. Then data processing unit will give the data, communicate the data to the master station. But before communicating the data to the master station, the data, if it requires any kind of conditioning, any kind of manipulation, then it is done by the data translation application. So once the data is fit to be sent to be shared with the master station, then it will be shared.
Sir, excuse me, I have one question.
Yes.
Sir, tell me that uh, data processing application, which I understand is only do the processing, but whenever data is communicated, it is from the physical I/O application. So, how can we say that data processing application communicates with the master station. I think physical I/O application is always sir. You got my question, or I have to repeat again?
Can you repeat it? Because I was unable to hear in between. I think whether my internet was having problem. I think yes. I could hear only half of it. Can you repeat?
Question is the communication I/O from master station is from the physical means. The processing of any processing where the processing is done, it cannot communicate with master. I think processing is done at a place, but from IO, physical IO, the communication takes place to the master. That is my question.
Hmm. Yeah. So what is happening is the physical IO will communicate only physical means it has yes. So physical IO, the communication through physical IO that is through hardware component. RTU has some certain channels which are its hardware. So it is a that is why it is called physical input IO. It is not wireless. So but communication between master station and RTU is wireless. So that is not through physical IO. Is it clear?
Still, but still, my question is where the processing is done, it will not never communicate with the master because
No,
processor
actually,
is okay in a
processing.
high level level, but the communication is always in the bits or what you say zeros and ones. Okay, or in analog also communication may happen, but the master station is always connected with the IO where the communication is taking place, not with the processor. That is my
So what I'm saying is that entire RTU is a microprocessor based device and it has several components, hardware and also software. So processing part is done in software part, and that hardware communication also has two types. Two type of hardware are there. One is physical, one and another hardware which is providing this wireless communication. So communication with master is happening through this. It can happen through both physical IO as well as through wireless. So it depends where RTU is, where the RTU is present. So
definitely
if it is at a remote
definitely
location, then the communication will be through wireless medium.
understood, sir. But definitely the processor will not communicate with master. That is I'm sure.
Yeah, processing part. Its name is processing, but actually the processing is done by the translation unit, data translation unit. I was saying that before sending the data to that master station, this translation application, it is doing any kind of process. As you can see, the data translation application manipulates the data before they are presented
Sir,
to master station.
sir, here you see the data processing application presents the data to the master station. That is my what is a question.
And
Data processing
yeah,
application, how it is presenting data to the master station.
so you are confusing with the name, I think, because it's saying it's processing application, so it means it should do processing. I- You're saying correct?
Yes, yes, sir.
No, it's but
Yes.
it's not like that. Actually, the processing is done by the translation application.
Let us move ahead, sir.
Sir, I have doubts, sir.
Yes, yes.
Sir, like SCADA systems, which are presently in actually worked on the IEEE 61850, right?
Yes.
For protocols. Every substation automation, correct that.
Mhm.
For every in the substation, every data is collected by the IEDs from each equipment. That is sent to the RTOs in the substation itself, right?
Yes.
And the data is transferred to the control center or master station, which is uh, uh,
Which
center
is
somewhere around data
maybe
center.
SLDC or NLDCs.
Through what communication will
Yes.
through which communication, a wireless communication or a dedicated like every station.
Yes. I
Communication
missed
will
the
there
last
because
part you asked.
a dedicated wireless system will.
Sorry, I could not hear you. The voice is breaking. Can you repeat again?
Hello,
Yes.
hello.
Yes, Karish.
Am I audible now?
Yes, good.
Sir, is a dedicated any network wire network will be there for collection of data from RTU to the control center
The
or wireless communication.
PLCC is there. Power line carrier communication.
Sir, just can you explain me how the PLCC works between the substations?
The same lines that we are using for transmitting the power, same line is used for communication also depending upon the so these power electronic interfaces they will depending upon the frequency of the signal because the frequency of the communication signal and frequency of the power signal is different.
Okay,
That is why
but
the hmm,
in every substation they are having some wave traps to just avoid that high frequency signals not to enter into the substation, right? In the starting itself it will be there between the substations. It is manageable, but how the data is collected to the from RTUs to the control center, I'm asking. In the distribution management system also, is there any in distribution management also PLCC is used, right? Or anything? Because if the data is not correctly correctly communicated to the control center, it can be misused, or any might be any damage can happen, right?
yes, correct. Now we are also using fiber optic cables. It is a wired
Fiber.
and it's very
Okay.
fast.
Yes.
Especially for distribution system now, fiber optic cables are being used.
Fiber optic cables. Okay.
Yes.
Okay. Okay. Sir, is that fiber optic cables will be if they are laid in the ground, or somewhat it may damage in anywhere. Uh, how what is the strength? What is the strength will be? Mechanical strength is high or okay.
It is because fiber optic cable around it there is a lot of protection is given so that inside that fiber is not damaged.
Okay.
Although the fiber is very thin, it's very
Because it's a glass kind of
yes,
thing, right?
but
Uh,
outside it we have a lot of covering. Just like underground cables, we have so much
mm,
insulation and other kind of coverings are there. Similarly, these fibers also they are not just laid down. They are laid down inside some cubicles either
okay.
inside of some pipes. So above that cable also there are pipes within which they are passed. So they are buried. So there is lot of protection available, just like
Okay.
underground cables.
Okay. Sir, what is the difference between SCADA and human machine interfacer? HMI. Hello.
It's a part of SCADA.
HMI is a part of SCADA.
Yes.
Okay.
Okay, so
Sir, the SCADA system will be used for in every industry, right? Just what is a control system will be used in the generating plants? The same SCADA system,
correct. Correct. It is same.
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 So okay,
It's just work done is different, but same control. We can see entire each of all the even gas plants, different types of industries. They have these control center where they can monitor each and every process of that what is being going on. So in
okay,
industries also, manufacturing industries, big plants are there. So they have a control center where they can monitor each and every step on that
okay,
panel. So that is also a SCADA. But now in power system,
okay,
we are moving to WAMs, wide area monitoring
okay,
system, using PMUs. So they transfer data
okay,
using this satellite-based communication. We are
okay,
using that now.
okay, sir. Go ahead.
Okay, so let us move ahead. Yeah, this is the same thing that we discussed.
Sir, what is the uh,
Yes.
smart grid and what is the use of smart grid? Will it explain, sir?
Eh, this was we covered this in last class also, but okay. So quickly, will I can tell you that.
Sir, this is my first class, so that's why I'm asking.
Okay, so just like we have conventional power system. In conventional power system, if we include communication as well as these IT devices, sensors, and all these things, technologies, in communication, smart sensors, smart metering, in with this conventional power system, and we can achieve several new functionalities which can make the grid more reliable, more robust, and more efficient. And as a result of which, we are able to provide more facilities to consumer also and improve the overall performance of the grid. So the new technologies which are enabling these all these functionalities, they all together combine to form a smart grid. So initially in conventional power system, we only have one one way communication. The entire generation is happening, then transmission, then distribution. Consumer cannot communicate with the generation or transmission. But now in smart grid, there can be bidirectional power flow as well and bidirectional communication also. So in conventional power system, there was no bidirectional power flow. The consumers which are at home, so suppose these residential consumers, they could not inject power into the grid. But now because of these small solar PV panels, they can do that. Even at distribution level, different voltage levels, power can be injected into the grid and can also be consumed from the grid. So all these things are changing. So main thing we can say bidirectional power flow as well as bidirectional communication capability. And these things are only possible when we have a good communication system, WAMs, and everywhere we need to have a control over everything. So for that we also need sensors. So all these things together will make the grid smart. Is it clear?
Yes, sir, clear, sir.
Yes. Shall we move ahead?
Sir, how many classes are completed till
Only
today?
one. So we had only one live session. That was last week. Every week we are going to have one live session. This is a 12-week course, so there will be 12 live sessions, out of which we have had only one. So this is second live session.
Okay, sir.
So now,
Weekly once only class, sir.
Actually, there are three live sessions: two on Saturday, 4 to 6, 6 to 8, and one is on Tuesday from 6 to 8. You can join any of these three.
For week we have 3 days.
Or 2 days, Saturday and Tuesday.
Saturday and Tuesday.
Yes.
6 to 8.
Saturday 2 to 4 and 6 to 8, and Tuesday 6 to 8. The timings and links you will receive in your email also, and you can see announcement section on the portal also.
Okay, sir.
Yeah, so let us move to smart metering. So in smart metering, first thing is to measure the signal. That is signal acquisition. Then the signal conditioning block is there to remove any unwanted signal. We want the 50 hertz voltage or current signal. So we need to remove any kind of higher harmonics or frequency. So that thing is done by this signal conditioning block. Then these analog signals are converted into digital domain. So ADCs are used for that. And then in digital domain the computation is being done. Any kind of arithmetic or system update. All these computations are done in digital domain and then they are communicated.
Sir, nowadays we are using smart metering. In olden days, what we used,
Even now, yeah, smart meter is there, but we have only one way communication. Earlier, we were using this electromechanical meters. They would have one disc which would rotate.
Sir, which type of communication is this? Is it fiber optics or wireless?
Yeah, these will be wireless only. It can be fiber optic also. If the then we need to have entire network of fiber optic communication. So
Sir,
for
why?
that
Because
also,
I
yeah, we
think
have to.
that wireless is not reliable. So
So that is why we always have a backup. So although adds to the cost of the infrastructure, but for the backup, it's wired is always reliable. So if you want to increase the reliability, we can have two type of communication. Just as in power system protection, we always have backup. There is primary protection, then we have a backup protection. Backup of backup is also there, but increasing these backup adds to the cost of the system.
Just one question, not related to, not technical. Uh, the presentation that you are showcasing, will it be available afterwards? Will
Yes, yes.
Okay, okay, all right. Thank you.
On the portal, you can see one tab, problem solving tab.
Uh-huh.
If you click there, you will find a Google Sheet. In that, all the three sessions which are being held, their YouTube link and the drive folder for this presentation is also available, so you can download from there.
So it is under Ask a Question
No,
tab.
no,
Yes.
it's on the left side, leftmost bottom, problem solving session. You will find one
Oh,
video.
yeah, yeah. Okay, okay, okay. All right. Thank you.
Okay, so then sorry, we discussed the distributed energy resources and discussed two sources. One was solar and wind. So at residential sector, we can have these different types of sources. Solar photovoltaic and which we have seen. Since it's already available, we can see. Even small wind turbines are also being developed that can be placed on our rooftop. That is also possible. Some micro turbines are also being developed for that. And then emergency backup generators also we can see in commercial complexes. It is still in residential. complexity also it's there. And then natural gas fired fuel cell. All these are option for residential sectors. And then for commercial and industrial sector, combined heat and power system it is one of the most widely used. Then small hydropower is also possible depending upon the availability of the uh, water resource. It's limited to the geographical location. And then wind turbine, fuel cells, solar photovoltaic, and biomass combustion. So before moving on to the solar, just wanted to just mention the largest solar plants which are available in the world. So you can see the largest solar plant is around 15 gigawatt, which is a huge capacity. It's in China, and then after that, second it's India with Bhadla, which is there in Rajasthan. It's 2.25 gigawatt. Similarly, in Pavagadh also we have a 2 gigawatt solar power plant. These are some of the biggest solar power plants. So this is the solar energy conversion system we can see. So PV system can be of two types. One is grid connected and one is the off grid system. So both the basic principle is this that the energy from the solar, the sun rays which results into activates which imparts the photon onto the PN junction and then there is a generation of electricity. That is why its name is solar PV because of photovoltaic effect. So there is generation of electricity and after that there is energy inversion and conditioning block. Since the output of a PV panel is DC,
Excuse me, sir.
yes.
Sir, I have a doubt in photovoltaic cells. Sir.
Hmm.
Sir, actually, the photovoltaic cells are connected like that. It consists of 36 number of cells, which comprising 9 rows of cells. Sorry, yes, 9 columns of cells and 4 rows of columns. Am I correct, sir? How it is equivalent to 12 volt?
Hmm.
36 cells, that is 9 columns and 4 rows configuration with a combination of series and parallel connections. How it becomes 12 volt photovoltaic system? What calculations behind this? Sir, am I audible, sir?
Yes, yes. You are saying
Shall I
30.
repeat? Shall I repeat my question, sir?
Yes,
When
yes.
we consider the photovoltaic cell
Hmm.
that has 36 number of cells, which
Hmm.
are arranged in the combinations,
9 by 4.
9 number of columns and 4 number of rows.
Hmm.
This is what shows in the PPT, PowerPoint presentation. My question is how this configuration with the series and parallel connections, how it produces 12 volt and how the output voltage is equal to 18 volts.
Hmm.
Yes, sorry,
Yes.
19 volt.
Hmm.
Output voltage becomes 19 volt and the cell photovoltaic cell voltage is 12 volt. How it becomes so?
Hmm.
What calculations behind that?
Yes. First of all, that output voltage is not 19 volts. That is open circuit voltage, VOC. So open circuit voltage is always more than the maximum voltage that the cell can provide.
Okay, sir.
Okay.
So my question is how it
Hmm.
becomes
How it
or
becomes
what
12
call?
volts?
Yeah, yeah, yeah.
Yeah. So 9. If it is 9 by 4, so they are arranged in a. So 9 cells are connected in series, and then these are connected in parallel. Correct.
Yeah, 9 number of cells arranged in column wise and 4 number of four four rows and 9 columns are there out of 36 number of cells. 9 into 4 becomes 36.
Yes. And
I think it's
each.
available in the next
So
slide. I think so.
I know. I think I have not put that. So
Okay, okay.
okay, let me draw it.
Yeah, yeah.
So here, just
Sir, what is use of PV cell photovoltaic?
just let me draw this. So you're saying 9 by 4.
Yes, sir.
So this is 4. Okay.
Yes, sir.
And VOC is 19 volts. So
Yes, sir.
if we have this 4 in parallel,
Okay, sir.
then what will happen?
Sir, for parallel, current is adding and
Current
voltage
is,
is common. Current is adding.
yes,
For
voltage is
series
same.
connection, voltage is adding. Yes, sir. For nine number of sir, for parallel connections, voltage is adding. Sorry, for parallel connection, voltage is constant and the current is adding. For series connection, voltage is adding. Sorry, voltage is adding and current is same. Am I correct, sir?
Just one question I wanted to ask. Is this a actual PV panel or it is a hypothetical question?
No, this
Actual.
9 by 4 is an actual. It's available.
No, no, voltage values.
Yeah, voltage value is also 12 volt is available.
Okay.
Yeah, my question is how it becomes 12 volt for this arrangement. What is the configuration? How the cells are? How many cells are arranged in series, and how many cells are arranged in parallel, and how it becomes 12 volts? Sir. This is my question. Exact question.
What is the output of one single cell
Sir,
voltage?
that becomes zero point 0.5 to zero point 0.6 volt. I think so. Each cell produces zero point 0.5 to zero point 0.6 voltage.
12 divided by. So if you consider this,
Even if we consider two rows are in series and only two are in parallel, I mean together are in parallel, that means there will be 18 cells in series. Still with zero point 0.6, it won't be 12 volts.
it is 9. If there are 9 in series,
There
then
can be 18 also in series depending upon how the configuration is. So sometimes it would be connected like two, all 18 are in series. So there are actually two rows of 18 cells in parallel in 36. Even though physically they are like that, their electrical connection would be like that. So it can be 18 into 2 as well.
yeah, sometimes it is directly 36 cells all in series.
Yes,
Although
yes,
it is
that is,
shown like this 9.4, but they are
yes,
all in series and
yes,
each cell is producing around 0.33 volt of
yes,
output. So it's a
yes. So
36
depending upon,
cells, yes, all connected in series.
yes. So depending upon what is the cell material and what is the VOC of that specific cell, you will understand whether all of them are in series or it is a combination of series and parallel.
So here what is happening, 36 cells are there, they all are connected in series. So if you divide 12 by 36, you will get 0.33 volts. So each cell is producing only 0.3 volt here. and the VOC is different from the actual
But
voltage.
each cell produces zero point 0.5 to zero point 0.6 voltage, sir.
It depends upon which type of cell we are using. So for different types of cell, the voltage which it can produce is different. If it is
Okay, sir.
monocrystalline, polycrystalline, thin film, it depends upon the material which we are using.
Which material produces 0.33 voltage, sir, for this configuration?
That I will have to check. I don't remember.
Okay, sir. Okay, sir. Thank you.
But VOC is certainly it's different. We will see in subsequent slide when we will see the characteristics. That VOC is when there is no current is being drawn from the panel. Then the voltage across its terminal will be VOC. But at that time, it cannot produce any power because no current is being drawn.
And one more doubt, sir. Actually, when we are developing any mathematical equations, we are representing the matrix as row into column. Am I correct, sir?
Matrix means
Number of rows into number of columns. This is the standardized practice when we are using matrices. But while we considering this photovoltaic cell, we are representing instead of row into column, we are specifying column into row. That is nine number of cells arranged in column and four rows. Why it is so, sir? We must follow some standardization.
this is not related to with matrix. I don't know means why is it called 9 by 4 or not 4
Yeah,
by
this is
9.
what my little confusion, sir. The how it produces 12 volt. Actually, it is correct one. Nine number of columns and four number of rows. If it is so, how it is connected in series and parallel?
Sir, actually, these questions, okay, you can always get from the PV cell manufacturing, those who are manufacturing. This is not an academic question. I think the answer we will get from those who manufacture this PV cell.
Okay, sir.
Yeah,
Okay, sir.
all
Thank you, sir.
these that is correct. Means all this
My my
output and
question is, sir, Gagan sir, my question is, now, as we know that generator produces both active and reactive power, but this solar cell, they only produces active power. From where we will get reactive power in the system from this PV generation cell?
although the cell produce active power, but because they are producing DC and we have to interface it with AC grid, so we in between there is an inverter. That inverter can provide reactive power.
But
So
sir,
all
see, generator also has, okay, very huge, what is the reactive power producing capability.
Hmm.
But I don't think that that inverter which is there with the solar cell, they have such capacity.
Yeah, that is true. They have a limited capability, but they do can provide because solar cell itself cannot provide any reactive power. So it's only the inverter which can provide. So it all depends upon its capability, its rating, how much reactive power it can produce, it can supply.
But I don't think that inverter come with that what you say rating that the inverter will also produce so much.
Inverters currently, so can I help here?
Yeah, sure.
Yeah. So inverters can produce even 100% reactive power. That depends upon, as rightly sir was saying, depends upon the specification of the inverter. There are inverters that can only go from point 0.8 to point 0.8 power factor. There are few inverters which can supply 100% reactive power also. So it will depend upon how the inverter is designed and how the control system of the inverter is designed. Accordingly they can do it. You have all the types of inverters available in the market.
That is good input. Thank you.
Yeah,
Remember that. And also, it depends upon although the inverter may have capability, but it depends upon the grid codes also. They should also,
yeah, they should allow, I mean,
the grid
yes,
code should also allow that they can provide 100% reactive power.
yes, but it
So,
is yeah, technically possible.
yeah,
Whether from grid code, whether from compliance point of view, whether it is allowed or not, that will depend, change from region to region.
that is also good that means they can provide entire 100% reactive power.
Yes, yes,
So they can provide different types of services also.
yes,
So in
they
future we
do
will
provide. Yes, they do provide ancillary services. The
Hmm.
only difference is they cannot provide sudden very high energy, any solar system. If you want to have, for example, they provide very high starting current for certain very high loads, it can provide you power but not very high energy. That is the only limitation.
Yes. Because they have a limit on current also. And that is also one of the challenge for
Yes.
protection
Yes.
system. How to
System doesn't won't
detect
work.
the
Yes. Yes.
overcurrent is
Yes.
fault
Yes. Yes.
because they
Yes.
limit the fault current. Okay.
Yes.
So shall we move ahead? Then I think we have a lot of slides remaining today. Uh, so this is for grid connected PV system. So we have a PV array, then we have inverter or power conditioner, and it will go to the panel, and then it can feed the AC loads, and the remaining power can also be fed to the electric utility, or when the solar is not available, the loads can be fed using the power from the utility. Similarly, we have a standalone system. So for this, even if grid is not present, yeah,
Sir, excuse me, sir.
yes, yes.
Sir, this slide, previous slide, I have a doubt. Please
This
go
one,
to previous slide, sir.
which one? This one,
No, no, next one.
next one, this one.
Yeah, yeah, this
Yes,
one, this one.
yes,
So actually,
yes.
in that configuration, we are using grid to vehicle and vehicle to grid configuration. Am I correct, sir?
Where here? No, it's not electric vehicle. It's for if you are
Yeah,
wanting
even
analogy,
home, yeah, even home too. Right. What is the power we are generating with the help of PV array? We can supply to grid too.
yes,
Yeah, yeah.
yeah,
So
grid.
actually,
Hmm.
yeah, yeah. Actually, when we are synchronizing one of the alternator with the grid, we had to follow certain conditions like frequency must be same and the phase sequences must be same and the voltage magnitude is also very same, right? So in that cases, what methodology we are adopting to synchronize frequency, voltage, and phase sequences and all for this case, sir. Actually, with the help of inverter only, we are going to convert again DC to AC. Then it will be supplied. Whether synchronization is also required for this case, or how it is going to be deal with it. Sir.
Yes, that will be required because
It's required.
right now, yes, it's always required because right now the converters that we are using for solar or even all the converters they are grid following, so they need a grid reference. So whenever they are connected, the point where they are connected to the grid, that is called point of common coupling, point of interface. We will see that in upcoming lectures also, week 3 or maybe week 4, 5. So there you
Okay,
will
sir.
see there is one PLL, one
Yes, of course.
phase lock loop is there, which is used
Okay.
to because that takes reference frequency of grid. So
Okay,
frequency
sir.
should match. Based upon that frequency, the PLL locks onto that frequency and then it will be able to feed power into the grid.
Okay, sir. But the electrical power generated with the help of PV array in home and all, domestic appliances and all, we are generating small amount of voltages only.
Hmm.
How the small amount of voltages is going to synchronize with that of grid voltage, sir?
No, but we are the voltage which the solar PV is producing at a home. It is going
Yeah.
to inject at the same voltage level, right? Because it is a 240. See, if it is single phase, then it's a lower voltage, not 11 kV. We are not
O-
injecting. If it is at home, if it is at 11 kV, then the AC output will also be 11 kV. That is not a problem.
Okay, sir. Thank you, sir. Thank you.
Okay, so let us move. So this is standalone system where we have grid connection is not there. So it is mostly we can use them where remote places where uh, grid accessibility to the grid is not there. So there we can have a PV array. Then charge controller is required. The charge controller can take information from battery. So it will monitor the battery performance. And then the battery can supply both AC and DC load. So if it wants to supply AC load, then we need to have an inverter which will convert the output of battery, which is DC, into AC. So this is already DC, so DC load can be fed. So charge controller plays an important role. So it will check that the battery is not overcharged, so it has to maintain its SOC. So SOC should not go. It should prevent both overcharging and over discharging. It will also reflect, show the status of battery, state of charge, its health, all these things, state of health, state of charge, all these things can be monitored by the charge controller. It also prevents electric overload. Then we saw modeling of solar PV. If you want to model a solar PV, then we have one. This is the model we use. Here, this is the shunt resistance, this is the series resistance, this is diode, and this is the photo generated current. This is the final current I cell, which is generated by each of the cell. So this equation reflects this current I cell. Is this equation correct, which is written here? Is this equation correct? So we need this I cell. This is IL. So if you want to write KVL, oh sorry, KCL, what will be the equation? Anyone of you? This should be negative because this current is being generated. Some current is going through this, some is going through this, and the rest is available here. This should be negative. So this is the model which we use for any kind of simulation. Whatever we do, you may use MATLAB, PSCAD, any kind of EMTP or RSCAD, even OpenRT. There are so many simulators are there. So they all use this type of model. This can be further complicated, but this is the simplest model that can be used. So that is, all these equations are written behind. When we press a button, a run, we click on run, these equations are being solved behind. That is why if we want to know, if we want to simulate, we should know the behavior of all these elements that we are going to connect in to make an entire system. How the solar is behaving, how the wind is behaving, what are the equations governing them. If you want to know in detail, that is why modeling is a very important aspect. These things tell us this photo generated current, it depends upon the short circuit current coefficient, and this cell temperature. And also on this, what is the level of irradiance. This is one example of how the in actual power system, solar power plant, how these solar panels are connected, solar cell or strings are connected. These are, this is one string. So we saw here, right? This is one cell, and this connection of these cells, just as we call that, we saw that 9 by 4. So it's a 12 volt module. So such modules are connected in series. This becomes one string. So several such strings are connected in parallel, and this is called a string combiner box. So all these parallel strings are combined together here. So there are several combiner box here, and then they are connected to the inverter. Then the inverter output is connected to a transformer, and then so this is a 5 example for a 5 megawatt grid connected solar plant, and which is being connected at 11 kV level. So this is further its detailed diagram is given here. So each of these string has 19 modules, and there are 16 such parallel strings which are combined by this string combiner box, and then there are such 9 string combiner box for each inverter, and there are 5 inverters, and each inverter is rated at 1 megawatt. Then it is connected to a 11 kV switch. If it's a very huge power plant, just as we saw 2 gigawatt, then it will be connected at a very high at transmission system level. So overall in this there are 13,490 modules, and each module power output is 365 watt. This is peak. WP means peak power. So can you tell any one of you what is meant by this WP? Whenever we say that a bulb is consuming 60 watt, LED is consuming 20 watt, we always say watt. But why are we saying WP here? Is there any reason for that?
Peak.
Maximum output power, sir.
So when
It
will
is power at STC, standard test conditions.
yes, correct.
Maximum power at STC.
25 degrees Celsius, 1000 watt per meter square
Square
radians.
irradiance.
So this is the maximum possible output of that module.
25 degrees C cell temperature, not ambient.
Hmm, correct. So ambient temperature also affects a lot the output of
Yes.
the solar panel. If the temperature is high, then the output will be affected.
Low.
It will be low. Correct. In several, I think in California, there was a rolling blackout in California. So at that time also, the output of solar was reduced. Even output of wind farms were reduced because wind was not blowing and temperature was very high. It was in August, temperature was very high, so output of solar was also reduced. So they had this problem.
Sir, can you explain with reference to the temperature how the energy is?
Actually, that I will not be able to explain
Okay, okay.
this time
Just
because it's a part of our assignment. So that is why I'm not able to explain. Otherwise, next, if you're not able to understand,
only
in
with the
next
temperature,
class
I
you
am
can
not
ask.
able to understand. With okay, okay,
Okay,
sir.
but it's my because we are not allowed to do that. So
Okay,
in next class, I will surely explain that
okay.
because tomorrow is deadline. Next class we can discuss it again. That is why I have not put that slide in this today's session. This is another example for a 5 megawatt grid connected solar power plant. So I have taken this from IEEE presentation. This is also displaying the same thing. Then, so this is for, we can go to Akshay Urja portal and check. They always update it. Actually, I forgot to update this. Now we can see up to June 2023 also. Then, largest onshore wind plants. This is China is leading both in solar and wind. They have 8 gigawatt of onshore wind plant in Gansu, and they are going to increase it to 20 megawatt. Sorry, 20 gigawatt. In India, the highest, this largest wind plant is in Tamil Nadu, Mupandal, 1.5 gigawatt. Then Jaisalmer also, around 1 gigawatt. So now wind is also mostly, now we are moving into offshore wind plants because of steady winds in oceans and also because of the higher wind speeds. And that's why the offshore wind plants, they are going to have huge wind turbines, very huge. Can anyone of you guess what would be this output of one offshore wind plant? Output of a single wind turbine. Any guesses? What could be the output of a single wind turbine? Any
Any
random?
any specific wind turbine you are referring
No,
to?
any. Means I am saying offshore wind plant. You can even tell for onshore wind plant. Means,
Onshore or in megawatt, even in
yes, both. But means how much megawatt? I am asking. Means you can how much? Yeah. Just make a
1
guess.
megawatt is very common.
Hmm.
Uh, uh,
1 to 3 is common.
three,
Yeah. So these 1 3 megawatts. These are generally we use it for onshore plants.
yes.
Even for onshore plants now we have up to 7.2 megawatt. So
Mhm.
can you guess for onshore wind plants what would be the capacity? If
Uh, no, don't know. It won't be a. It would be a random guess. No, I
so
have no
we'll see
information.
it. We'll see it. So what is the maximum available capacity nowadays? So this is for this is for offshore wind plants. Largest. Oh, UK dominates in offshore wind plants.
Sir,
UK.
what is the difference between offshore and onshore wind
Yeah, onshore
plants?
means on the this continent. Offshore is inside ocean. So whatever plants that we have in Tamil Nadu, Jaisalmer, they are on the continent. They are not in inside our ocean.
So, so this is one wind tunnel. Sorry, windmill. 12.18 gigawatt. If I say first one,
Which one?
hey, you said na ki that offshore is single is very high capacity. What is that?
No,
15
this
gigawatt.
you will see that offshore. Nowadays we have around 16 megawatt, not gigawatt. Gigawatt is for entire plant. So this 1218
Because
megawatt.
of velocity, steady velocity of
Yeah,
a
yeah.
wind speed,
Yes, correct.
the
Hmm.
power will be
Yes,
high
because of steady winds
for
and
offshore.
very high wind speeds, we get output that we can get from a wind turbine is also high. But for such a huge wind turbine, we have to the mechanical design has to be very robust, and it should be able to handle those very high typhoons. Those cyclonic winds also they should be able to bear because they have to be there in the ocean, and also the what means the design is very complicated
Sir,
because they have to flow.
excuse me, sir.
Yes.
Sir, is the table related with wind plants or photovoltaic power station, sir?
No, these are for wind plants. So 1.2 gigawatt offshore wind plant in UK. So
Okay,
here
okay.
we can
But
see
the
that.
table first column shows the PV power
Oh,
station.
sorry, that's a mistake.
So, okay,
Correct,
sir.
correct.
Okay, sir.
Thank
Thank
you
you.
for pointing out. I will change this. This is wind power plant. And so here you can see these are the turbine and the models which we have. So these are different companies. Siemens, Gamesa. Siemens is very famous company. Then Vestas is also there. These two are the most common one. These most widely used ones. And UK is leading in offshore wind plants. Even other European countries, we can see Netherlands, Denmark. Denmark is creating one entire renewable island. So they will have several wind plants on that island. So that work is being done. It will take around by 2030. It will be operational. So now we are also moving to this offshore wind plants. In India also we are planning new offshore wind plants. So let us move to wind. So wind distributed generation resources we discussed. how this energy conversion happens, and different types of wind turbines, type 1, 2, 3, and 4. And then how wind power is calculated, wind power curve, and torque speed characteristics. So this is the conversion process. We all know that it's which energy is converted into which energy in wind energy system. What happens? Conversion happens from which type of energy to which type of energy?
Kinetic
Kinetic
energy.
to electrical.
So we can say it's first it's kinetic, then it becomes mechanical. So here up to this it is mechanical, then it becomes electrical. So finally we can say it's kinetic ultimately to electrical. So we have a rotor, then gearbox to increase the speed because the rotor will move at a slower speed, and we need a very high speed. For 50 hertz also we need so much high speed. 3000 RPM is required. So for that gearbox is required. And generator is there, then we have converter transformer to interface it to the AC grid. Yeah, so we will now see some questions. Again, we will see that the capacity of that wind turbine, how the pitch control is there. We will see that while discussing the questions. So this is the first question. Which of the following is not a part of RTU, remote telecontrol unit? We will discuss there are five
D.
components of
His,
RTU. Which?
historical D.
Yeah, so
Historical.
historical server is a part of which component?
Mass.
SCADA.
Yeah, so SCADA has as we discussed, SCADA has three components. So one is master station, second is RTU, then we have communication system. So this historical server is a part of master station. Correct. So in smart meters, which type of communication technique is used?
C. Zigbee.
C. Any other option?
Public
Either
switch
either
telephone.
it's C or it's D. Sorry. Go ahead, please.
Who else is speaking?
Sir, option C, sir.
D. It
No,
will be D.
yeah, it's D is correct. So we can use this. So Ethernet is a wired communication. Zigbee is wireless. This is also wired. So these two are wired. First two. So yeah, see, earlier we used to use the line which we are using for these landline phones. We used to use that internet using same line. Ethernet, this is LAN. Fiber optic can be also cables can also be used for providing this Ethernet services. And then Zigbee is a wireless communication protocol. So answer is D. So next question is third generation of solar cells are made up of which of these material technology?
Advanced thin film.
Yes, correct. What about first generation?
First is C.
Yes, first is C. Second generation is
Second is thin
Thin
film.
film.
yes A. And so third is B. Correct. No, sir. So this is another example of a solar plant advancement in solar technology. This is floating solar plant. So can you tell what is the advantage of solar this floating solar plant?
space.
Space for, means space requirement, you are saying?
Yeah, space requirement. We can utilize that extra space available in that.
Yeah, that is correct. That is one of the advantage. We don't need
Second,
land. There is no.
second, the water evaporation we can.
Yeah, but yeah, that is true. We can. That is advantage for water body, but what will be advantage for solar cell? Oh, means what is the advantage of solar plant being uh, developed on that water body? So, from the point of solar plant, what is the advantage?
I think cleaning, less cleaning will be required.
Less cleaning,
Shadow is not going to be happen, sir.
shadow. Yeah, if it is very
Shadow.
open, then yeah, shadow. That we can say yes. Depending upon the
And
area, that will also depend upon area. But it's if it's an open area, then shadow will not be there. Correct. And what else? Actually, so okay. Let me tell them. Anyone else want to try? There is a very important reason. One very
so 71 percentage of water surrounded by globe.
no. It's okay. Water is there, but what is the benefit of putting a solar plant on water body? That is the main question here. It's a very important point. One thing
From
is
cooling point
correct.
of view,
Yes, cooling is a very
cooling
important
point of
point because
yes.
water bodies, they do not heat up quickly. Their latent heat is higher. They take time to. There, you can see ocean. Its temperature is almost around 27 degrees always. It fluctuates very less. So even if land temperature may go up to 40 degrees, water temperature is still 27. So cooling point of view, it's very important. It's very good, very beneficial for solar plant. They provide inherent cooling is there for solar plants. And then you can see one picture is here in this third and second picture. They are from this. This is one solar floating plant in Switzerland. In Alps, they have put one plant on a lake in one of the lakes. It's at a very high altitude. So one thing is cooling, temperature is very low there. Second is the sun rays which come on these snow-capped mountains. It again reflects. So
Albedo
that
effect.
also, yes, albedo effect, correct. So that also improves the performance of solar panel. So these are some of the advantages. That is why we are using them now. In India, so we have this NTPC Ramagundam in Telangana. This largest still China is dominating here also. Three Gorges Dam also they have 150 megawatt solar floating plant.
So in India also, Ramagundam has solar that floating plant.
Yes, yes,
India, where they have some what found or some water body.
yes, yes. Even here, Tata Power Solar in Kerala also this 92 megawatt is there. So this first picture is of this NTPC Ramagundam plant. This is first same. Okay, so these are another certain few advancement in solar technologies. One is, have you heard of these transparent solar panels?
No.
Yeah, so we are
No, sir.
now. This is one of the new developments. It's around 2 3 years. So if we have these transparent solar panels, we can use them in our in cities. We say these are heat islands because of refrigeration. Oh, sorry, air conditioning and this transportation and these glass buildings. We have these huge glass buildings, and all of them have these glasses. If we use these transparent solar panels, the heat which they are producing, we can use them to for air conditioning. Entire building, if it is having these windows made of these transparent solar panels, then can help a lot. So there are certain companies which have started producing these windows which use these transparent solar panels. Then another is the solar highways. This is picture from China. Even I think France or Germany, they have also made one solar highway. This is this China. They have developed one solar highway. So these these are electric vehicles which can dynamically charge using these solar panels. This is another.
Sir, what about the cost aspects, sir? Actually,
Yeah,
when we are considering the cost of a PV cells, so it's more costlier. That is the main drawbacks of a PV cell. While we go for advancement in PV cells like transparent solar panels and solar highways and all, what is the cost involvement, sir? Again, it becomes huge cost, you know.
correct. So it will take some time to become commercialized, but still they have started developing. So maybe in next 5-10 years we will see them being deployed throughout the world. They will certainly, it will take few years for the
Okay,
deployment.
sir.
Cost is really very high, especially for transparent solar panels. Even solar highways compared to normal highways, it will be very cheap, very expensive. And then solar paints are also available nowadays. You can paint the surface and it will act as a solar panel. Now we have flexible panels also available. You can fold them. You can put it over any surface, on roofs, different types. So that all these things are now coming up. So maybe in future we will use them more as their cost reduces. Yeah, this is the next question. So define the characteristics curve IVP in the format y axis variable, x axis variable. This is y axis, this is x axis. You have to tell what is there on y axis and what is there on x axis in both the curves. So which curve is
A,
this? A is IV,
IV and
IV
VP.
and PV. Correct. So this is current and this is voltage and this is power versus voltage. So this is the short circuit current. This and this is the open circuit voltage VOC. So we have maximum current, short circuit current, and maximum voltage at VOC, open circuit voltage. Then why don't we have maximum power at these 2 points? Can you tell? It's it's very easy, but still, although we have maximum current available, we have maximum voltage point, but we don't have maximum power available at these 2 points. What is the reason?
Because circuit is open, so power will not flow.
Power is the combination of its voltage and two current.
Right. So in both the
So
points,
yeah,
yes, one of them is zero. The power is V into I. So if this is maximum, this is zero. If this is VOC, this is zero. The product is zero. That is why we can see here also power is zero, here also power is zero. And in between you will find some point, which is this knee point, where the power is maximum. So this is the maximum power point. And we use these MPPT tracking algorithms to track this point so that we can extract maximum power from the solar cells. Okay, so let's move to the next question. This is a small numerical, very easy. You just need to know what is fill factor. So, do you remember what is fill factor?
Vm Im by Voc into ISC.
Yeah. So it's VM voltage at maximum power point, current at maximum power point, open circuit voltage and short circuit current. So it's given that fill factor of a solar panel is 0.75, open circuit voltage is 72, short circuit current is 18 ampere, then you have to find the maximum power delivered by the solar panel. So what will be the answer? So can you quickly find out what will be the answer? You just have to multiply. Formula is written in front of you.
So it
Yeah.
is 0.75 into 18 into 72
Yes. So
volt.
what? Yes. So this is simple. This is the maximum power, and we know all these three values. This also, this we know. This is 72 volts. This is 18 amperes, and this is 0.75. So we just have to multiply.
972.
Correct. So this is 972 watts. So answer C is correct. Yeah, so I was asking the same question before also, which of these equation is correct. So you just have to check sign. Rest all the terms are same. So which one is correct?
D.
The model is this.
It is C.
D.
So this is RSP, RSH cell. This is IL and this is I cell. So we are saying D. Who is saying C? C and D are same or different?
D.
Who is saying
Different.
C?
It's a D.
Yeah, it should be D. Because this voltage is the voltage across this diode, and voltage across this diode is V cell plus I into R cell. D is the correct answer. And then again there is a drop of this, because this voltage is V cell plus I into R divided by RSH. Okay. This IL is going into this ID and I RSH. So I cell is equals to IL minus ID minus this current. Let us say I RSH. This is the diode current ID. So answer D is correct. Next question is, what is the function of gearbox in wind turbine generation system? This also we have discussed. What will be the answer? Which one?
B.
B. B
D
section.
is correct. It steps up the speed according to the requirement of electric generator. Next question is, according to Albert Betz, the maximum efficiency of wind power generation system is. We have not discussed this, but it was mentioned in the lectures.
C.
So this maximum theoretical limit is 59%. So from whatever wind is available, from that we can extract maximum 59% of energy. Beyond that we cannot extract from wind.
So even that inside the shore, what we discussed, it is 59 only.
Sorry, can
Offshore and
you?
onshore, both
Yes,
data
yes. Yeah, wherever, anywhere you
finance.
can place that, but the maximum energy that that you can extract from that available kinetic energy is 59% only. So the wind turbines that we have at present, I think exactly I don't remember, but they are below 50%. I think we're between 45 up to 45% maybe some of them. I'm not remembering it, but it's up to 45%. They are able to extract between 40 to 45%. But still, there is a lot of scope. It's difficult to achieve entire 59%. It's the theoretical
But
limit.
still,
Till now, we have not reached.
it is better than thermal, because thermal,
Yes.
I think the efficiency is 30%,
Yeah.
33%.
In this ultra mega power plants, we can reach up to 40%, but that is maximum. So, but wind, yeah, wind is better than thermal. Even solar, so much better than solar. Solar, we don't even have up to 20% efficiency. That is very low. Wind is much better in that sense, and also India has a lot of wind potential. In coastal area, we have so much a big coastline, so we can have several offshore wind plants. That is why the CEA has in its document for 2030, they have advices, they have planned few offshore wind plants, some in Tamil Nadu and some in Gujarat. So next question is, in the fixed speed wind turbine, the speed of turbine is controlled by controlling which of these following?
Pitch, B.
B.
B is correct. Pitch is correct. Pitch of the wind turbine. So we'll see what is this pitch. So this is a typical wind turbine. This box is on this tower. Just a minute.
So pitch is of for the blade only.
Yes, correct. Pitch is for blade. So this box is over the tower. And so this is a tower. So there are two types of control here in wind turbine. You can say actually there are total three controls. One is we try to track the maximum power. Then there are two other controls. One is this yaw control, and for that we have this yaw motor. So what is happening on the tower? This entire thing is resting on the tower. So this motor, it can move this entire this rotor, blade, this hub, and this entire block. All these three can move together. So they can move like this over the tower. So this is done by this yaw motor. So are you able to understand this? Means for maybe how should I? If this is
Yes, yes,
if this
yes.
is the tower or this is the hub, so hub can move like this on the tower, like this. It can move. So this is done by this yaw motor. So if suppose the wind direction is changing, so the entire turbine can move over the tower in the direction of wind. If it is not in the direction of wind, then it cannot generate. So that is done by yaw motor. And how is it going to decide what is the direction of wind? So that will the will come from wind vane. So wind vane is the sensor which will uh, monitor the direction of the wind. So the output of this wind vane goes to this control of yaw motor drive. And it will be able to align the entire turbine in that direction of the wind. Then second control is this pitch control. So there are three blades, and we can see here this direction. So this blade can move. So their direction is not fixed. They can also move. So there are three servo motors for each of these blade. And depending upon the wind speed, because we want to extract the maximum power, so for each wind speed, for because we have this curve for wind also we have a curve. We want to operate for a different wind speed. This curve is different, and we want to operate at the maximum point. So to operate at that point, the angle of this blade has to be optimal for each wind speed. So depending upon the speed which is measured by this anemometer. So the in output of this anemometer will go to this pitch control, and accordingly it will change the this angle of pitch angle which we call. So this blade will be rotated to certain degrees.
You want to say that whatever may be the wind speed, even 100 to 200, the speed of the three blades is a constant in this.
Yes, the speed is not constant. And speed is changing. It's a variable speed drive. Speed is changing, but whatever the speed may be, for each speed there is a different curve. So whatever the speed may be, similar to solar, whatever may be the irradiance, even if the irradiance is low, but we want to extract the maximum power available at that particular irradiance. Similarly, whatever may be the wind speed, we want to extract the maximum power at that particular wind speed. So for that, pitch control is used.
But my question is that RPM is constant. Let's say
No,
suppose
no, it's
today
not.
the
No, no, it's not.
100 kilometer per hour, and after 6 hours because of cyclone it is 200 kilometer per hour. So
Okay.
that RPM it must be double of that, na? When there is 200 kilometer per hour.
Oh, generator frequency is same, no?
No, no, not. I'm not talking about generator. I'm talking about the RPM of the
RPM of
wind turbine.
yeah, it will change
RPM
because
of
wind speed is changing, so it will always be changing. It will never be same.
so that is why that is the name which is said that fixed speed wind. So that is not
Oh,
correct. Wind is always changing, so RPM is also changing.
wind is changing. Fixed speed means the output of the that's the wind. Here, wind speed is always changing. Wind speed is never same here. So when we say fixed speed wind turbine, what does that mean? And that doesn't mean that the wind speed is same. That is type
So that
1
means
wind turbine in which whatever may be the wind speed, we try to move it at fixed speed. But that creates problem for the wind turbine because if the wind speed is very high and if we still want to rotate the turbine at the same speed, then there will be mechanical stress. It will be very difficult. Wear and tear increases and the life cycle of the wind turbine also reduces. Therefore, we do not we no more use that type 1 wind turbine, which was the fixed speed. That was moving, yeah, that was having fixed speed. But that is not practical. It will reduce the life. In stormy wind condition, to maintain the fixed speed will create a lot of mechanical stress on the wind turbine blades, on turbine shaft also. So that is why we are not using the type 1 turbine anymore. Is it clear?
yes,
Yeah. So that is why we moved to this type 3. We are using DFIG based. That is a variable speed. So depending upon the wind speed, the speed of turbine is also changing. But at that particular speed, we want to extract the maximum power. So for that, the blades are inclined in such a way that we can extract that power. So we can still be at this point on this curve. So that angle of that pitch angle of the blade will help us achieve that. Just as in solar, we do the same thing. Although irradiance keep on changing, but still we are able to extract the maximum power from the solar.
What about the frequencies, sir? For that situation, frequency is varying continuously now.
Yes, frequency is varying. So there are two types of converter. There are two converters in that. One is AC DC and then DC to AC. Finally, this converter will be producing a 50 hertz signal, voltage and current. So frequency of this may be different. It will depend upon the wind speed. Yeah, so I was talking about this. Year on year, the capacity of each wind turbine is increasing. You can see in 1980s it started with 50 kilowatt. Then in 2000 up to 2 megawatt from each single turbine. 2018 10 megawatt. And rotor diameter also you can see 190 meter is very huge. It's huge. And also in converter also you can see now we are using DFIG and even PMSG is also being used. So these are some examples of the wind turbine which are available, commercially available. They are also being deployed. They are being used in several plants. Mostly these are being used. These are most widely used. This is a new, this recent one. This is MYSE is a Chinese company. So they have made this 16 megawatt wind turbine. They have also come up with this 18 megawatt wind turbine, but it is not commercially available right now. So maybe after 2 3 years, they are planning to launch this 18 megawatt also. So it is. They say that it's prone. It's not prone to this. Yes, it can withstand these cyclonic storms also. It has a rotor diameter of 242 meter, which is very big. Then another company is the Siemens Gamesa that we have seen in offshore wind plants, UK. Most of the plants they are using this Siemens Gamesa wind turbines. They are also providing 14 megawatt wind turbine. This Vestas is also having the highest 15 megawatt wind turbine for offshore wind plants. And then for onshore, the maximum capacity available right now is 7.2 megawatt. This is by Vestas and by Siemens Gamesa, they provide a 7 megawatt wind turbine.
So what is the height of this turbines? Height of this?
Hub height. So you can say if
At
it
least,
is
at least,
uh,
at least, at least 1.5 times of blade length.
yes, correct. So if blade length is 118 meters, so that is correct. At least it should be 1.5 times. So I think once I saw this around, I think not exactly remembering, but around 166 meter. I'll have to check. You can see on this link which I have provided. I think it's around 166 meter. You can check it again. So it's very huge. These wind turbines are quite high. and to erect, to maintain them in these oceans. Uh, Ocean waves are also there, so their construction is also very different from onshore. Then the power extracted from this wind turbine has to be brought on land using these HVDC cables, underground sea cables. That also adds to the cost. Yeah, this is done. So next question is, what is the function of yaw drive? This also we have discussed. Which one is the option?
C. C.
Yeah, C is correct. It turns the rotor according to the wind direction. Yeah, so this is next question. The blades in the turbine works on the principle of.
D. Lift and drag both.
Yes, correct. So these blades are designed in such a way that their structure is such that there is a pressure difference created on both sides of the blades, and as a result of which it is from low to high pressure there is a lift, and because of wind also there is a drag. Then next question is, light generated current in solar cell depends upon. So we saw this equation of light generated current IL.
All.
Yes, correct. It is also, it depends upon that short circuit temperature coefficient. It depends upon that cell temperature. It also depends upon the irradiance level and also depends upon the short circuit current. Answer is D. This is the last question. It's a numerical example. Although it's a big question, uh, maybe you can. I have provided the solution in the slides. So, first of all, let me read the question, then you can tell me how we can proceed with this question. So, there is a one rectangular land of 5 acres, and there are four wind turbines, which are placed at the four corners of the land. The blade length is 52 meters. Yeah. Okay. Before that, let me read it. Then I will define what is cut-in. So, cut-in wind speed, rated, and cut-out speed are given, and for a particular day, average wind speed for 7 different time spans are also given. We have to calculate total available renewable energy from the land for the entire day. Air density is also given. So this is a curve for power versus wind speed, where V is the wind speed. So the typical curve is like this. After this it is 0. So this is V in, the cut-in speed. This is the rated speed, and this is the cut-out speed. And this is power here. This is P max, maximum power or rated power, you can say. So same thing is written here also. So you can, when the wind speed is below V in, cut in speed, the turbine cannot generate. That wind speed is not sufficient to generate any electricity. And similarly, when the speed is too high, more than the cutout speed, then it's not favorable for wind turbine to keep generating. It can damage the wind turbine, so it will stall. It will using the yaw drive, it will change the direction of the wind turbine itself. So then it will stop till the speed is reduced. It comes within the range. So the range within which it can generate power is between cut in to cut out speed. So between V in, the cut into rated speed, at rated speed it can provide the rated amount of power. So between this there is a this linear relation. So here it is considered a linear relationship, although we can have quadratic here Even cubic also, so I have seen in some papers cubic also being used. So we can use this relationship. This is a linear relationship. Then after from rated to cutout speed, power is constant. The same, this is the mathematical model for this PV relationship, the power and speed relationship. So we are given that for each time span there are how many blocks? There are 7 blocks of time. For each of them, average wind speed is given. And now we want to calculate the available renewable energy from the land. So can anyone of you tell me how can we proceed with this question? What should we do? Since you can tell me steps. What will be the first step? Then what should be the second step? And one more thing you need to calculate here first. What is P rated? So how can we calculate the rated power?
P rated has a formula like
Yes. What is the formula? Do you remember?
that V cube into that I don't remember density of air, then what is V square V cube rho into that length of that uh, blade length.
Yeah. So this is the rated power formula, half rho A V cube, where rho is given. It is air density in kg per meter cube. Velocity is also, we have velocity. Rated wind speed is given here, which is 12 meter per second. So we have to substitute this, and area, how we are going to calculate area? Area is pi r square. So what is blade length is given. So R is this 52 meter. So can you calculate this rated power? Let us see whether you are able. Means substitute all these values. Pi, this is 52 square. PW. Yeah, correct. Energy is summation of PW into duration of time. That is correct. Yeah, so area will be this. Substitute area here. Velocity, this V is 12 meter per second. Rho is 1.23. So try to calculate this rated power. What will be the value? Okay, so did you calculate?
So what is the V we have to take for this V?
V is this 12 meter per second. So it is given it.
Why
Cut
where it is given 12?
It is given it. Cut in speed is 3 and rated speed is 12. Cut out speed is 18 meter per second.
4.977, so around 5 megawatt
I think you have made some mistake. Have you
somewhere.
missed half? Have you missed half or something?
I'll do it again.
Okay, so this is rho is 1.23, area is pi r square. So where r is 52 meters and velocity is 12 meter per second. So speed is 12 meter per second. So calculate it once again. Anyone else who has calculated rated power? 135.716. Is this watt, kilowatt, or megawatt? Please always specify the units. No, and what is this is not correct. Means you have made some mistake. Also, because 135 watts is a very small amount, that much energy we can easily consume at home. This is a 5 acre land, so generation should be, yes, correct. Karthikeyan,
Yes,
absolutely correct.
9.27 something.
Karthikeyan has correctly.
8.80.
I don't know what mistakes are you doing. Are you substituting all these values? Rho 1.23, V speed 12 meter per second and area pi r square where r is 52. If you are doing all these things, even after that you are getting wrong answer, that means there is calculation mistake. So correct answer is this 9.23 megawatt. Karthikeyan has done correctly. So yes, Arti correct. 9.027 or
Yeah.
9.02.
Yeah, 9.027. That's
Okay, correct. So this is the rated power. So now what we have to do next? Next, what are we going to do? So we have rated power. We know VR, we know V in, we also know V from this table. So now what are we going to do?
for each time segment, uh,
Yeah.
find
So
out the linear.
okay. So
Yeah.
you first tell me in. So we have for PW we have three types of. Means you can say three. We have three segments of curve. In which time block which segment will be used, that you have to tell me. So between 8 a.m. to 11 a.m. wind speed is 6.2 meter per second. So which of these segment will be applicable?
Second, linear.
Correct. So we have to use. So I will write it here. P W. Let us say linear. Okay. PW linear. Uh, between 11 to 3 p.m.
Same.
Again,
Same.
again linear, again
Yes.
linear.
Linear. And
So
what about this?
6 to 10, it is not linear.
It
It,
is
it is that means constant.
correct. So this is rated power. Then next,
Again constant.
yes, this is also constant. And what about this one? 18.4.
Ze-
18.4 it will be.
Zero.
Yes. So this is 0 because it is more than 18.
It is
And
more than 18. Yes.
yes. And this, what about 12.2?
Again, it is linear.
No.
No.
No, no.
Rated. Rated.
Yes, correct. So this will be rated. So now what you have to do, you have to find this, we already know. Rated, we already calculated. So you have to find these three values for each of these wind speed. So substitute V by 6.2, 5.6, 6.5, you'll get three values. And then you have to calculate this for each of these duration. How much is the duration for this? This is how many hours? 8 to 11.
3 hours.
3 hours.
3 hours.
Yeah, so for each of these you have to find out hours, number of hours. So this will be 0, means hours are there but energy will be 0. So if we have find out power for each of these, multiply it with the duration, you will find energy. Some. Yes, Ajit, are you saying something? Then you have to sum it all. So, yes,
Then we have to multiply by 4 also because there are 4 turbines.
correct. Very good. Correct. So this is area. This is rated power, and for this duration, wind speed, power for each of these times span, and then we have summed and multiplied by 4. Who has raised hand? Someone had raised hand. Okay, so is this clear? Do you have any doubt in this question?
So practical question that once that cutout speed is there,
Hmm.
so then at that moment it is the windmill will align with the that parallel to the wind flow. So that the zero resistance is
Hmm. Yes, that yes, we will change we will change the direction so that it is not affected by the wind speed.
so that mechanism is there. Otherwise, it will break.
Yes, correct. That is true. So we call it stall when we stall the wind turbine.
Stall is not a correct word. Why? Because stall uh, is associated with aircraft.
Yeah, but since they generally use this term, stall also.
Because that turbine blade is a aerofoil.
Mm-hmm.
All word is that means it will drop down to the ground, but it will never happen.
Mm. Even pitch angle can be changed through that.
But that is also not practical. Pitch angle changing automatically is not feasible.
No, it is done automatically. Pitch angle is being changed automatically only. We
Yes,
are
yes.
not doing it manually.
That is why these turbines are not in use.
Which
So
one?
in which the pitch angle is changing. So
No,
not,
no. They are being used, right? Pitch angle control is being done. For extracting maximum power, we have to do pitch control. They have servo motors inside
but but
for
but
each of the blades.
but practically what you said now that type 3 is there.
Yes.
That the speed is changing, but I don't know. I have never seen that. I have yet
No,
to see
they
that
have
it's constant.
pitch control is used there.
So even that type 3 also pitch angle is used. I don't know. I have.
Yes, they use it. Now all the turbines they use the pitch control. They have servo motors for each of the wind blades, and using them they will control it.
So automatically they are controlled, or some
Yes,
control action is there.
it is automatic. It's a closed loop control,
Okay.
and auto manual can also means nowadays they are also using this digital twin technology. So these new turbines, especially this I mentioned this Chinese, even Samsung Gamesa, these offshore wind plants which are very high power, they are using this digital twin technology. So the digital twin technology is that the physical process which is happening in the wind turbine, that entire process, this entire mathematical model is being simulated inside a processor on a system. And they will have some sensors on the actual wind turbine. From that, this sensor will send data to that model, and then that model can do an all real-time analysis and can also give back any signal to those sensor to change pitch angle, whatever we want to do. That is also available nowadays. That is called digital twin.
In the wind turbine,
Yeah.
if when you control the power, typically what is the uh, steps in which it can be controlled? How accurate is that for wind?
It's accuracy in sense. It's a because we are using power electronic converters. It's
Hmm.
even control is also very smooth. It's
Okay.
not fixed step is not like that. There
Okay.
are not any fixed steps
So,
as such. We can have
I
a
mean,
smooth control
can
because we
can
are using
can,
PI
can
control.
it be on the level of few watts or
Okay,
kilowatts?
in that way
That's
you
what.
are
Yeah.
saying.
Yeah. Yeah. Is
Yes.
it that precise, or it is typically in few, say,
But why
100
we want
kilowatt?
That
but
I'm not sure up to means what is the precision
no, no.
level
But
up to
my
what.
question is, madam, why we want to control the power? Let
Uh,
let it generate and it will go to the grid.
yes, but then if the grid cannot handle that much power, if they have to curtail the power,
Grid is always
then
deficient of power.
no. We have to do that. But in that case, whether they completely turn off some of the wind turbines or they can also control the power, that was my question.
Yeah, that we can do. We can control the power. So what happens actually right now the policy is that whatever the renewables are generating,
Hmm.
they are allowed to feed it into the grid,
Hmm.
depending upon what their schedule is. So
Exactly. So
what
that's what I'm
happens
saying.
is
You can't do it all the time. The utility, typically for these bigger power plants, they will have to have control, right?
so what
So
happens is they are given some one day schedule they
yes.
provide. So they
Right.
will say that within 10-15% margin, we will, let's say one wind farm is saying we will produce around 1 gigawatt plus minus
Yes.
10%. So
Yes.
if they go beyond that, then they will be penalized. They will have to
Exactly.
reduce their, otherwise they will be penalized, so they have to
Yes.
reduce, so they can
Right.
reduce it. So they will
Right.
be given time of 15 minutes, maybe 5 minutes, that I don't remember exactly, but there are guidelines for that. So they have to, if that they are overproducing,
Mm.
then they will have to curtail it. They will
Yes.
change the pitch angle, and they will not operate on maximum power point at that time. So they
Exactly.
will their power output will be less than the maximum power point.
Yeah. Yes. So that was. I mean, I was just curious that how accurate is that to the kilowatt or watt
That I
level.
will have to check.
Okay. Okay. That's thank
Maybe if it, because it's rated in megawatt, so kilowatt precision would be there.
you.
Up
Okay.
to watts is there, and because watt will not matter that much.
Yes. Yes. Yes.
Kilowatt is also sufficient.
Yeah, but even in kilowatts, I mean, it's hundreds of kilowatts,
Yeah,
or
that is possible.
it'll,
That
yeah.
would be possible.
Okay.
Yeah, so we're done with question. Are there any more doubts?
Suman ma'am in the chat has mentioned about imbalance penalty.
Yeah, that is same thing which we were talking. That ma'am was saying that if they are not complying with the schedule, their schedule, they will have to pay a penalty. They will be penalized. So whenever there is an imbalance from the schedule, they have to. All the generators have to do that. For any kind of fault is there, any outage is there, they are not able to maintain that much schedule. They have to mm, bear. Generally, overproduction, if it's there from solar wind, then simply they have to curtail. That is why they are planning to put storage. So when there is overproduction, they can store the power in that battery, and then also try to provide this, they call it RTC, round the clock generation. So they can provide that RTC even during when the solar that irradiance is low. The storage can be used to maintain the output of the solar or even wind for that matter. So now that is why several companies, Adani, Reliance, they are trying to come up with this storage. In future, we will see solar storage, solar wind storage. I forgot to mention one thing. We now also have these solar and wind hybrid plants. Recently, this Adani green energy company, they have come up with 600 megawatt solar and wind hybrid plant in Jaisalmer. So in future, we'll see, because what happens. Solar is most there during the daytime only, and wind is mostly during this midnight. Depending upon location, also it may vary, but it is there at night also. So if solar and wind hybrid plant is there, it can also produce during evenings and night time also, and can also help us in meet the evening peak demand. So that is a good option, and if storage is also combined with that, then it will be even, it can provide other type of services also. China has also come up with a hybrid hydro and solar plant. It's a very huge plant. I forgot to mention that in the slide. I have that slide and I have not included it here. It's a very big plant. So all these things are now coming up. So I think we should close the session now. It's already 8:07. If
Last class PDF
Yeah,
and
it's available. If you will go on the Swayam portal, on the leftmost bottom, there is one tab, problem solving sessions. Go to that, click on the link, and you can download all the sessions PDF for presentation. You can also access the recording, YouTube recordings from there. So if you have any suggestion for the for improving these sessions, the way we are going, uh, if you want some changes in that, you can always suggest me, so we can change the way we are uh, moving on with these sessions. But thank you, I thank you all for such an active participation. It's always encouraging when we are interacting. It's very good.
Thank you, sir. Can we get a recording of this session?
I'm sorry for the last session, the recording. I have put that recording on the YouTube, but that recording somehow video was not recorded. I don't know why, but audio is still there. So I have just included slides with audio. But today, I think both audio and video have been recorded. So that link is also available on that problem solving session. When you will go there, you will find one entire Google Sheet. In that, YouTube links are also available, and Drive link for a folder where presentations are available, that is also there. So you can get both the things on the same link.
Okay, sir. Thank you, sir.
Okay, so thank you all for joining the session. We'll meet next week, same time. Thank you.
Sir, Saturday there is no class.
Saturday is there from 6 to 4 to 6 and 6 to 8, but other TAs will be uh, taking those classes. I will be there only on Tuesday from 4 to 6.
Okay, sir.
Thank you.